Okay, good morning everyone, and welcome to this seminar on lashings and restraints for helicopter tie downs. Thank you all for attending this morning. It's very nice to be here at Helitech 22. A lot of visitors here today, and our stand is just round the corner if you want to come over afterwards. But who are Drall Industries? Well, we're a small independent engineering company. We're based down in St Leonard's on Sea on the south coast. There's about 35 of us and a fair number of engineers within that developing custom equipment. Just to give you a little flavour of our business, we are centrally located in St Leonard's in a new factory that we built just 2 years ago now. We took the benefit of the COVID shutdown periods to actually build a new factory. We were very fortunate, and we now have a very modern factory which produces a great many different bits of engineering equipment. The heart of our business is high-level accreditations, and we maintain AS 9100 for all our aerospace activities, and that also incorporates 9001 for all of our other more industrial activity. We also maintain DAOS approval for the military work that we do. On top of that, we hold the other accreditations that most large companies require now in terms of environmental and health and safety, as you can see on the slide there. So what do we actually manufacture? Well, the group is made up of three divisions: industrial, aerospace and utilities. Today we're looking at aerospace, but essentially we manufacture niche specialist equipment. This slide shows you a little selection of some of those things, and we make all manner of things from, you can see up here, some wing stands for drones, so somewhat appropriate to the other show that's up here today, through to shutdown cabinets for nuclear power station water treatment systems, dryers for radar and waveguide systems, and a whole range of sort of specialist ground support equipment. But today I'm going to concentrate on talking about the application of our lashings and restraints, which is the topic of today's seminar. Okay, so let's. This area can be quite confusing when we talk about lashings. What is the rating of my lashing? If you buy lashings or use them, sometimes you look at the literature that's put out by manufacturers. How do you understand what the ratings mean? What is the real strength of your lashing? Often it can be very confusing if you're not really familiar or you haven't really thought about the application, and particularly so when it comes to helicopter tie downs. So is the rating shown there the maximum safe working strength, or is it something else? Well, often it's actually the ultimate braking strength. So how do you use that bit of information? You obviously don't select the ultimate braking. You don't want it to break. You need some kind of safety factor. So I'm going to take you through some of the terms and some of the confusion of different ways that terms are described, and just explain to you our rationale for the safe use of lashings on helicopters. So, start off with what's the highest load I can use my lashing at. This is described in various ways, but the one that is perhaps best used or easiest to understand is design load, the load it's designed for. But it can be described in a number of other ways. There's a couple of standards there where it's called limit load. So that's the SAE standard and the EN standard, which is usually used for cargo restraint. Sometimes it's called the safe working load, less so these days. People don't like putting the word safe in there because it implies something has been decided which it hasn't been. So you still see it on chains a fair bit, but it's going out of favour in a general use. It's also called the normal working load. That seems to make some sense. The working load limit, another variation of the same thing. The rated capacity, or the lashing capacity. Lashing capacity is quite a nice one. Again, the words mean what they say. So the design load, let's call it just the design load, is actually the ultimate load, so the load at which it breaks, divided by a safety factor, and that gives you some measure of confidence about the performance of your lashing. So, next question, what is the minimum load my lashings will actually break at? What is the ultimate load? How is that determined? What else is it called? Again, confusingly, it can be called a few other things. It can be called braking force. Again, fairly obvious, and it is, again, as in the SAE standards and the ISO standard. It can be called the minimum braking force. A little bit more clarity. It's the minimum force it will brake at. It can also be called the minimum braking strength in some standards and applications, or the minimum braking load. So you can see, you look at various manufacturers' brochures, you will see some of these different terms, and you need to be aware of that perhaps. But essentially, the ultimate load is calculated from the design load times the safety factor. So we'll keep looking at that same equation. The three factors just tie themselves together. Here's a little video. I think this will run if I press it, showing you us testing. Oh, it didn't run. So I need to put that there. That's right. You should see this snap in a moment. I think that's it. There we go. And you'll see, basically that's how we test it in our rigs. And you can see where the webbing is actually broken. You're also testing the sewing on the webbing, and you're hoping that the webbing will go first normally. This is what it's designed to do, so you've always got a stronger joint than the actual material, so the weakest point is there. So, how is this all tested, and what happens in production? Well, typically an ultimate test will be done initially on a batch of samples, and then it will be done on a small sample of each production batch. It will be subject to a proof test occasionally. For some high integrity applications, customers will ask you to test every single one, but it's not generally considered necessary. But a proof test has to be above the design load, but not so near to the proof load that you're actually going, to the ultimate that you're actually going to stretch it or cause it to degrade. So very typically, it's called a proof load test or a test load. There are not quite so many variations of terminology for this, and it tends not to be talked about or published very much. But typically, it'll be about 1 1/4 times the design load that the lashing has been decided to be issued for. So I've talked around the numbers, the design load, the ultimate, but the safety factor is really the important issue, and this is really why lashings are often rated as ultimate loads, because you have to decide on each application what safety factor you're going to use and what the design load is going to be. So you don't put the design load on the lashing unless you have made that lashing specifically for one purpose. So again, there are a number of other terms we can use for safety factor that you may see. It comes over as factor of safety, similar. Coefficient of utilization, that's a bit more difficult to appreciate, but somebody obviously thought that was a useful term. But it is, as we've said, coming back to that formula, calculated by the ultimate load divided by the design load. So for the standards that I mentioned there, the SAE and the ISO, you will see that there is a minimum factor of 1.5, and that's pretty much true for most general lashings, and that applies for internal cargo lashings. it's more than adequate and it's used universally. The other standards that I've mentioned throughout are, the other one that I mentioned was 12195. That's specifically for road cargo. That has a specifically higher level of 2, and that's because when you're lashing on a truck, you have to allow for braking strains, and it's fairly predictable what's going to happen. You need a slightly higher safety factor because it's not a static situation. There's braking forces, there's moving loads. For helicopters, we generally recommend 1.5 as the minimum for a normal use, just tying down somewhere, perfectly adequate. In storm conditions, we would say a minimum of 3 is generally what is acceptable. So when you're picking a lashing, those are the kind of rules you should use. But I'll go on and explain to you a few examples and show you some of the ways that can be interpreted or misinterpreted in the future. So, back to what factors we should use. As I mentioned, normally 1.5, or for storm conditions 3. So let's take an example. Take a 145, and we know that the recommended lashing pattern for that is 6 tie downs. So if the weight is around 3,800 kilos, or I think I've done this example in pounds, 8,000 odd pounds, if you're going to go for a safety factor of 3, that means you need a rating of some 25,000 pounds or so. So that means if we've got 6 lashings, we need 6 lashings that are at least 4,000 odd pounds rating. So typically we would provide a standard lashing of 4,500 pounds, 6 of in a kit. That would be your standard lashing kit. That would cover you for pretty much all eventualities, storm condition or otherwise. That safety factor actually works out to 3.22. So, you know, there's always a little bit of rounding depending on using a standard product. But let's follow that through and look at what Airbus actually say about that aircraft. I have taken here some data, which this comes from the Airbus. There's a little Airbus app if anyone's interested. It's called ACH. You can find it on Apple and Android. And it's got all their standard craft, and it shows you the lashing patterns. So you can see here 3 lashings on each side. And as you might expect, 1 at the front, 2 at the back, where nearer to the centre of gravity. So that's always been specified and worked out by the helicopter manufacturer. They will tell you how many you need and where. And generally the rule is that you spread the load equally amongst those points. And that's so that you will retain it properly, won't allow for one end coming up or going down. So that recommends 6 lashings, which was what we used for the example I showed you. If we have a look in practice, here's a few photographs of, here's a 145. This particular one's been lashed down with 4. But you know, if that's normal use, they're not worried, then that's fine. That's a safety factor of 2.1, so more than the 1.5, quite acceptable for a normal use, flat. That's on a ship, I think, or a deck. Might be a windy deck, I'm not sure. Either way, that's quite acceptable. On the other hand, here's an example which does use our lashings, and you can see there they've actually got 8 lashings rather than 6. So they've decided to go a little bit overboard. Maybe they're particularly worried about their aircraft. That's a safety factor of 4, so that's well covered. But you know that's fine. It's down to your user really. Don't forget that you do have to tie the blades down as well. We don't generally sell blade kits. They normally come with your aircraft. They are considered part of the aircraft, whereas lashing kits are not. And they tend to get ignored and forgotten, and that's part of the point of this discussion, that they're not very well specified. Normally you will find that the aircraft manufacturer, somewhere in their manual, chapter 12 or somewhere like that, I think, will specify the pattern that you should use. So you should always start from that point. Again, that blade tie-down data has been snapshotted out of the Airbus app. A very useful little app if you're using their ships. So let's just have a little bit more look at an extreme example. I love this one. This here is the side of the QE carrier. They never designed it to take a Chinook, and on a visit they decided that they wanted to take it down to the flight deck, so they lashed it up, hanging over the edge. I'm not entirely sure the authorities thought that was a brilliant plan, but we think it's rather a nice photograph because those are our lashings. I quickly worked out the safety factor there's about 5, so they're definitely wanting to make sure they're not taking any chances there. We've actually got a big picture of this in our reception because I like the photo so much. But let's have a look at a few other aircraft that we've got some data for and some pictures. Here's a storm pattern for a Merlin, so that's a pretty large aircraft. That picture's quite difficult to interpret, but it shows in fact 18 lashings total in a storm condition, and that safety factor's sort of 7+. Now that's not necessarily what they always do, but that's what it shows. We've actually taken a picture of one here and drawn these on because this shows the full extent. We've never seen one lashed to the full extent, to be honest, but you can see here there's 2, 4, 6, 8, and then under here that shows 2 more, but they go underneath either way, so there's only 1 each side. So that makes 9 each side. If we just take a little look here, we can see another nice picture. I don't know if any of you have been around there and you've seen there's a Lynx right opposite our stand. We didn't know that was going to be there, but I did put this one here is being tied down in what you could call storm conditions. Having a little bit of trouble with the blades there, I think. Again, using some of our lashings, but the safety factor was about 13 there, so they were. But then what they tend to do is they come in and try and put 3 or 4 lashings on quickly to try and get as much retention as possible. In those sort of conditions, speed is very important. But again, slightly extreme example. But the whole point really is that if you're going to tie down your helicopter, you really need to think about these things carefully and calculate what you're going to do. Now, what type of lashing should you use? Obviously, I am going to say you should use my lashings, but I'd like to explain to you the features you should look for in a lashing for a helicopter. We always use an over-center buckle principle mainly for one main reason, is that it's easier and better to control than any kind of ratchet. You don't see people using ratchets. There's a big danger with ratchets that you can overstress them with a cheetah bar or whatever. And the thing I haven't mentioned so far is you have to be a little bit careful about this safety factor business because they don't publish it, but it's fairly my belief that the weakest point is going to be the mounting on the helicopter. So, you know, you might say you've got 13 times safety factor, but it'll probably rip the rings out of the helicopter before you get to that factor. And so that's why you need a little bit of guidance from the manufacturer as well. But the other big advantage of an over-center buckle design is that you can tension it by pulling it with simple body weight, and even the lightest of person can apply sufficient strength and lock it without worrying. But an over-center design isn't enough. Although they're very simple and generally foolproof, you've got to make sure that the design doesn't have any FOD hazards. It doesn't have parts that might snap in service and drop on the deck, fly up in your engines or whatever. So you need a little bit of thought there, not to use any old lashing. The buckle needs to be robust, and we always recommend a locking mechanism as well. When you're using it in awkward conditions, if you don't have a lock, then an overbuckle, although it does lock flat in use, needs a secondary safety factor. And as the load gets higher the rating of the lashing. You also need to be considering the unique design of the lashing. If it's not a ratchet, it's held by friction. You've got to make sure that you've got a high anti-slip feature in the lashing you're using, appropriate to the load. So let's have a little look at some product examples to illustrate this. This is our basic standard. It's a military tie down that we've supplied for decades. It's our 4,500 pound ultimate load, which is adapted for most smaller helicopters. If we take a look at the design, that's a traditional over-center buckle. No locking feature, not necessarily FOD proof. If you take a little look at the design of our product in detail, we have a locking feature here, which you can see, and also the design of feature of the central buckle is there to make sure that you don't get slip under full load. Moving up the range, the same principle applies. This is a 12,000 pound lashing that we used on slightly larger helicopters. This is a rather beefier design. You can see it's more substantial. It's got a higher strength, but it uses a similar set of principles. Again, a locking buckle mechanism. In this case, though, the profile of the retention over the belting is designed to make sure that it can't move under very high loads, and then that's our patented design, which we've been developed for many, many years. And that's our standard MC2 storm lashing, which is rated at 15,000 pounds ultimate lashing. So pretty much we don't go much bigger than that because that's heavy enough in operation. You don't really want a lashing that's any heavier than that because it's unmanageable, so you'd rather apply 2 than go bigger than that. In some cases, chain lashings are used, probably more on aircraft than rotorcraft, but they are used on some. This is our CA14 quick release coupling. I think this operates a little differently. Hopefully this video will go. There we go. So you can connect a chain, again, a very quick connect. The other end you can connect, quarter turn to connect the other end, and then once it's all connected, you can just tension it with a wheel in the middle. We also have an anti-vibration version, but it is particularly useful if you want to make a very quick connection of the product. Here's an interesting combination of that and the lashings, which is used on a number of navies, like this one. It has the quick release claw only, so you can just quickly connect it onto the deck and lash it to the helicopter at the other end, or either way around. It does depend on the helicopter you're using, but then you can just tension it quite quickly. That's a 4,500 pound rating again, because that's rated by, that is actually the MC one. It's just a combination of 2 products there, but it's designed for quick coupling as well. Sometimes in some ship operations people want to go in and put a couple of things on very quickly, so they might use those and then tie down with the ordinary ones. So what are there in terms of a few other considerations, a few final things to think about? Colour of the webbing. Colour, do you care? Well, it is quite important. We nearly always supply white. That's really because of night vision and rain and dark. White is traditionally the most accepted colour. There are those who want to have black or green or some other colour. It's perfectly acceptable if that's what you want, and they can be done to suit. And likewise, you can have printing added if you want to specify that that is for a particular aircraft type or some restriction. And we do that routinely to suit different customers' processes. You might say only for this aircraft type, not for another. The other crucial thing, particularly if you're going to embark on ships or specialist areas, not so much on general aviation fields, most of those have a fairly large standard ring, but you will find that on certain conditions you need special swivels or connectors. Sometimes the connections on the aircraft, so certainly some of the bigger ones, you need maybe to have a loop before you connect the hook in, because you don't want the lashing to be actually bashing on the side of the aircraft. But if you're just using a small aircraft, it's probably not going to be critical. And if it's on a ship, sometimes you have some strange deck plates. Sometimes it's very easy to connect to them. Other times they're slightly bizarre in their dimensions, and you need to take care if you're doing something special on a ship you've not used before. Quick connection, I think I've really already mentioned that, but it is largely when you want to do a quick mooring. In fact, on some of the military systems there are specialist manufacturers who make like spike mountings for certain frigates, etc., which we've seen. I've mentioned the QRC is ideal if you want to do something quite quick. And then the last thing, of course, is to consider the length of the lashing. A lot of our lashings come around 5 meters. That's normally enough and adequate. A few people want them shorter or longer, depends on your particular application and the location. But whichever way you look at it, your answer might be a custom lashing. We do quite a lot of custom lashings for different customers, and that's a specialist part of our business. So I hope that that's given you some flavour of how you should select lashings and restraints for tying down helicopters. You will find us, if I put this slide up, round on D94, which is just the other side of that wall over there. We'd love to see you and talk to you about any problems or issues that you have with restraints. So thank you very much for listening today. And I'll be hanging around afterwards if you'd like to talk to me about anything. Thank you very much for coming. Cheers.